Let's go over merge sort. Merge sort is one of many different algorithms that you can use to sort a list from lowest to highest, and it uses recursion and divide and conquer techniques. Right now, I'm using the CLR book. This is supposed to be a very good reference for algorithms. And probabilities and all the different necessary stuff for you to be a good computer science student. But for me, I thought it was very dry and pretty hard to understand because it's very mathy and technical. I wish there was a better way to teach topics like this, but it's an academic environment, so I guess being boring and technical is a given. But I'll try my best to explain this because this was one of the ways that I could kind of get a grasp on what was going on with this algorithm. So in the CLR book, it goes over the business logic first, the merge function right here. But I thought it would be better to go over the recursive function first. So this is what gets called. This is the recursive function that gets called to divide an array in halves until the length becomes 1. So if you have an array like this is the method that will split it to left and right halves. And this goes on and on until the length of this becomes equal to 1. So here you can see the parameters A, P, and R. A is the actual array. P is, you can think of it as the left end, and then R is the right end. And these are indices. So here it calculates Q, which is the midpoint. And normally, if you're using, any modern programming language like Java, it will drop the decimal points for you. So if you're using integer division or integer multiplication, and you're using, you're using mathematical operations with decimals in them, it will drop them unless you specify as float. But here, since this is math, you have to use a float function. So if it ends up being like 1.5, it'll drop this 5 and it'll become 1. So what it does is it just finds the midpoint, it adds the left and right ends, divides by 2, and that equals Q, which is the midpoint. So this happens until you reach length 1, which the comparison should, I think I left out the comparison. Let me check. Give me 1 second. Yes, I left out the comparisons though. So there should be something right here that says if P is less than R. Okay. So I'll get back to this later. So this, I mentioned that this recursive function splits the left one big array into left and right halves until it reaches 1. So this is the left half and this is the right half. So here is from left to midpoint, and then here is midpoint plus 1 to the right end. And since this is recursive, it calls itself, but before it does all of these operations, it first checks to see if P is less than R, if left is less than right, and if the length equals 1, 1 is not less than 1, so it fails this check, and these operations are not run. So then, if you have a function call like this, this is the merge and then merge and then merge division. If this fails, then this is the thing that'll be merging the two child arrays. So the merge, since these are the recursive functions, and this merge function is the actual business logic. It's the one that sorts the lower two child arrays in order. Now in the book, what happens is that it starts out as a parent array, and then the child array, um, uh, the parent array gets divided into two child arrays, and then it sorts by replacing the elements in the parent array. So if this was like 2 and 4, and that was 4 and 2, and this was 2 and 4, something like that, it'll replace the actual parent array. And I'm not sure if that's the best way. I think the better way is to create a new array, which is the example that I'm going to show you later. But that's how that's what happens in the CLR book. So if you look at the merge function, the business logic, these n1 and n2s, they're lengths of the halves. So this is the left half, and this is the right half, and it's calculating the length of the array. And this let L, it goes from 1 to n1 plus 1, and R goes from 1 to n2 plus 1, our new array. So it's initializing, so it starts out as a parent array, and then it's initializing two child arrays, L and R. And notice this n plus 1 and n2 plus 1, because this will come in handy later. Just remember this, because it's actually, when it's creating these arrays, let's say here's four elements, and then it's creating left and right, and it's actually creating one more empty space, which is right here, and I'll explain that later. So this for I equals 1 to n, it's iterating through the array, and it's copying whatever was here to the newly created child array. So if this was 2, this would be 2. If this was 3, this would be 3. If this was 4, this would be 4, and if this was 5, this would be 5. So it's these two for loops are copying whatever was in the parent array into the two child arrays. Now here is what's called a sentinel, and it's supposed to be kind of a check to see if the child arrays are empty. So you would fill the ends of the spaces, the empty spaces that you created earlier, you would fill them with infinity. Now infinity is larger than any integer, so that will come in handy later in this for loop. But for now, let's take a look at this. I guess the CLR book is kind of resetting I and j for use in this for loop. I'm not sure why that's included here. Now this for loop, it does the actual comparisons and the merging. So like I said, it's replacing the parent values, but I'm going to show you by creating a new array. So for the first two I and j for loops, it's reset by ones, and then it creates a new for loop using k as the iterator integer. Now, if you visualize kind of what's going on, it splits it into left and rights, and then left and rights. Now, I'll use this example right here to show you kind of step by step what's going on with the merge function. So if you use this 2 and 4 with that's split into just single indices, single arrays. The length of this is 1 and the length of this is 1, and we can show that right here. Merge. Let me clear all of this out. Actually, let me clear all of this out. Delete this. Okay, so use a different color. Merge. That's the array. The P is 1. Now Q, which was calculated right here, let me calculate Q right now. So Q is P plus R. So P is 1 and then R is 2. P 1 plus 2, and that's divided by 2 with a floor function. So that equals 1.5. 3 divided by 2 is 1.5. And if you floor that, that becomes 1. So the Q here is 1 and R is 2. So the N1 we calculate would be 1 minus 1 plus 1, which is 1. And then N2 would be 2 minus 1, which is equal 1. So you can see that the lengths of the child arrays are 1, both left and right ends. And then it simply copies over whatever the parent values were. So in this case, the left one would just be a 2, and then the right one would just be a 4. And then it attaches these sentinel infinity values to the extra space that we created. So here for k equals P2R. So for k equals 1 to 2, it's going from 1 to 2, if Li is less than Rj. So we reset the values here. So Li is 2 and then Rj is 4. So that satisfies this Boolean comparison. And then this new array that we create to store the sorted values would be, let's say this is k, right? K index 1, 2. K is 1, so since this satisfies, it would be 2. And then we increment I. When we increment I, the pointer, the array pointer would be at infinity. So when we do the next comparison, so we go back and reiterate through the for loop, k equals P2R. If Li is infinity, if infinity is less than or equal to Rj, which is 4, is infinity less than or equal to 4? No, that's not true. Else, ak is equal to Rj. Rj is 4, we copy 4 over, and then j increment, so the pointer is right here. Now this second loop is now, k would be at 2, and we're supposed to stop at 2. So that finishes the merge, and then we go back to our ancestor. So the operation that we just did combined these two into this one, and then we would do the same thing for this. This would have a child array right here, and then it would combine it into a bigger array, and then a bigger array, and then it sorts it at the end. So how you can think about this is that was just one element, but let's say we were comparing, we were merging this and this array. So 2, 4, and 5, 6. So what would happen is you would be, think of it as a deck of cards. So you can only see what's face up. If you had a 2 here and a 5 here, you would compare which is bigger, 2 or 5. Sorry, which is less, 2 or 5. And 2 is less than 5, so you'd put down 2, and then that consumes the card. So that consumes the card, and now you have 4 and 5. So when you toss that card over, what's underneath the 2 card would be 4. So you compare 4 and 5. 4 is less than 5, so you get rid of this 4 card, and then there's nothing here, and then it's just 5. You put down 5. There's nothing else to compare to, and then 7. And that's it.